In this video, I'm going to just show you a bunch of exercises that use the identities cosine of a plus b and cosine of a minus b. So those identities are here. You can pause if you need to review them. I proved these identities in another video, my previous video, and it was fun. So now we'll really just look at how to use these identities. So just a bunch of different exercises. So I'm just going to jump right into it. One way that you can use these identities is you can use them to help you figure out the value of certain expressions. So for instance, cosine of 105, you may not know the value of that, and you might think, oh, I can only do that with a calculator. But the thing to recognize, 105 is actually 45 degrees and 60 degrees. And so now that I have this written as a sum, I can bust out, right, my cosine of a sum and just apply that identity. And these are all values that we should know because we can find these values 45 degrees and 60 degrees. If you look on the unit circle, you can just read them off here, right? And so then I can just plug them straight in like this and sort out the algebra. And now I've got a pretty exact answer, minus needing a calculator for what the value of the cosine of 105 is. Okay, so I would also recommend, just to double check that this is right, I would say that you should verify this with a calculator. I verified it with mine. Just make sure your calculator's in degrees. But this is a really easy way to check if you actually got this right, if you applied the identity properly. So same thing if I have cosine of pi over 12. So now this is in radians. So you have to play around with it a little bit, but 3 pi over 12 and 2 pi over 12 gives you pi over 12, right? And so that's the equivalent of pi over 4 and pi over 6. So you really just got to play around with it a little bit. And so in this case now I can apply the cosine of a difference. And so I can just, plug everything in as you see here. And then again, I can reference my unit circle. So I wanted to have pi over 4 and pi over 6. So I can just take the information off of the unit circle, kind of plug everything in as you see here, and now I get square root of 6 plus square root of 2 over 4. So that's how you can kind of apply those. And then just one more kind of in this vein. Oh, and again, you can check this. Sorry, I forgot to mention that. You can check this. Make sure, if you're going to check this, make sure your calculator is in radians. And then, of course, if you have something like this, so you can also use the identity going the other direction, right? So this identity is really going to require us to reference cosine of a sum. So when I subtract these two, I know that I can add whatever the 2 degrees are there. So I've got 40 and 50. I can add those up to get that this is going to be cosine of 90 degrees, and cosine of 90 degrees I know is just 0. So that's one way you can use those identities. The cofunction identities, so those are really an extension of this difference formula. So just to show you that, you may not remember what the cofunction identities are. So the cofunction identities start with this. And if I were to just go through and apply the cosine of a difference, that here I am applying that formula. But cosine of 90 is equal to 0 and sine of 90 is equal to 1. So I can just simplify all of this, and this just comes out to sine of theta. And this is the cofunction identity, right? So that's kind of why we say the cofunction identities are just an extension of this idea. And here are all the cofunction identities. So going forward, we'll say that those are fair game. So very similar reasoning for the rest of these, even though we haven't talked about the difference of sine or tangent or whatever else. One other thing I want to note here, I've written these all in 90 degrees, but you can switch 90 degrees to radians and write pi over 2 instead. It's equivalent. Okay, so I want to just talk you through using the cofunction identities a little bit since we're on that topic. So let's find one value of theta that satisfies this equation here. Okay, so what you're going to want to do, I know that secant and cosecant, they have this relationship with the cofunction identities, but I really want to find where I have this secant theta. So you'll see here, right, so I've got secant of 90 degrees minus theta equals cosecant, and then cosecant of 90 degrees minus theta equals secant theta. So what I'm interested in is, so just to be very clear, so I'm interested in this cofunction identity, so I just want to show you why. So I'm interested in the one that will equal the theta that I'm trying to find. So I want to find the cofunction identity that in this case would equal secant theta. And secant theta, remember, according to the cofunction identity, will equal cosecant of 90 degrees minus theta. So then what I can do is I can pop that cofunction identity into the function and rewrite my function like this. And now that both sides say cosecant, I can actually just pop the degrees out and solve for theta like you see here. And then it's just algebra, right? So then it's just theta is equal to 90 degrees minus 72 degrees. So that just equals 18 degrees. So that's all you have to do for there. So I would recommend that you try that with this one. Same idea. So still working with the cofunction identities. I strongly recommend that you pause the video, give this one a try, and then hit play when you're ready or when you're stuck. So when I look at these, so remember, I'm interested in solving for theta here, so tangent of theta. So when I look through my cofunction identities, I want to find the one that equals tangent of theta, so I can make that substitution. So just to make that nice and visual, so I've got tangent of theta. Here's my cofunction identity that equals tangent of theta. And now I can take this side and plug it in for tangent, like you see here. And now that I have both sides are cotangent, I can just pop out the degrees and solve for theta. So theta will be 90 degrees plus 44 degrees. And so then that just comes out to 134 degrees. And so we can also do this with radians. So remember with radians, I brought up that you can switch 90 degrees to pi over 2. So personally, I would recommend that you try this one more time if you're still trying to get this. Hit pause and then play when you're ready. Okay, so as I look through my cofunction identities, so I'm interested in the one that will equal cosine of theta. So I'm interested in this one. I'm going to switch the 90 degrees to pi over 2, like you see here. And then I'm going to do that same thing where I'm going to replace the cosine with the sine of pi over 2 minus theta. So now I've got both sides are equal. So I can just take pi over 2 minus theta equals 5 pi over 6. And then I can just go ahead and do the algebra to figure that out. I'm going to need a common denominator in this case, but I ultimately get negative 2 pi over 6, which I can simplify to negative pi over 3. Okay, so going back to those identities that we were talking about at the beginning of the video. So write cosine of 180 degrees minus theta as a function of theta alone. So to do that, this is actually really just asking us to apply that identity. So in this case, we're talking about a difference. So if I apply the cosine of a difference, so just look at what happens if I'm asked to do something like this. This is the only way that this can really work out. So I plug in 180 and theta into their proper spots. So I apply the identity with 180 and theta. And so in this case, cosine of 180 is equal to negative 1. Sine of 180 is equal to 0. So here's how this all kind of shakes out and simplifies. So this will just equal negative cosine of theta. And so now I have this in terms of just a singular theta. So that's what this is asking for. Another exercise that can come up with this. So suppose sine of s equals 3 over 8. Sine of t equals negative 12 over 13, where s is in quadrant 1 and t is in quadrant 3. Find the values of cosine of s plus t and cosine of s minus t. So we're going to start with s plus t. And so just remember, this is the identity, right? And what we want to do, we want to visualize this situation, because I think once you visualize this situation, it just makes it a lot easier to figure out how to fill these things in. So, and before I go any farther, so just notice, I know the value of sine of s, right? And I know the value of sine of t, those are given. I do not know the values of cosine and cosine of t and cosine of s. So anyways, so if I go back to visualize this information, so sine of s is in quadrant 1, sine of t, this is in quadrant 3. So if I just label this information, here's my s, and then here's my t, and if I label the sides, so remember, sine is opposite over hypotenuse. So here's so for this one, my hypotenuse will be 5, and my opposite side will come out to 3. And then for sine of t, so this will be negative. The hypotenuse, remember, is always positive, so this will be my 13. So I've got all this information here. So now I'm visualizing what I've been given in the proper quadrants. And then you just want to find the missing sides, which you can do using the Pythagorean theorem. So, you could use your a squared plus b squared equals c squared. I'm going to omit the work for that. I personally would recommend that you just pause and find the missing sides, because I think you know how to do that, and I'm trying to keep this video short. So on this side, the missing side is negative 5. So if you were to solve for this in your calculator, you'd probably get positive 5. But remember, we're in quadrant 3, so this side must be negative, just based on the quadrant information. And then here, the missing side will equal 4. And again, I just found those using the Pythagorean theorem. And so now we want to find the values of cosine S and cosine T, which I can very easily do with this visual, because cosine S now, it's going to be the adjacent over the hypotenuse. So that's 4 over 5. And cosine of T, this will be, oops, let me see, I'm missing my negative here. Okay, boop, there it is. All right, so cosine of T is negative 5 over 13. So again, that's just the adjacent side over the hypotenuse. Okay, so now I've got all my information. So I've noted those here. So I've been given sine of S and sine of T. Now I found cosine of S and cosine of T. And so now it's just a matter of just plugging all this information in using the identity, like the formula for the identity. So cosine of S 4/5, cosine of T negative 5 over 13 minus sine of S, that was given, sine of T, that was given. So then I can just sort this all out. I just used a calculator to help me figure this out, and I left it in fractional form just to keep it more exact, so I got 126. And then, remember, we still have to do cosine of S minus T. So I'm just going to switch this now to cosine of S minus T. It's still all the same information. So once you figure this out, now it's just a matter of just, plugging in the formulas. So here's my identity that I need to leverage, and then I just plug all that information in again. Same ideas, right? Nothing different here. And when I do this one, I get negative 17 over 26. Okay, and then what would a trig identity be without verifying a trig identity? So I've got verify secant of pi plus x equals negative secant of x. Okay, so remember, like, one of the key things that we want to do when we have something not in terms of sine and cosine is we want to rewrite things in terms of sine and cosine. So secant of pi plus x is going to be the same as 1 over cosine of pi plus x. And now from here, this is where I can use my good old identity. So if I now apply my identity, my denominator would turn into this whole crazy thing. But we know the value of cosine of pi and the value of sine of pi, right? So cosine of pi is negative 1. Sine of pi is 0. So I can plug all that information in. So this now becomes negative cosine minus 0, which ultimately just equals, 1 over negative cosine. And if I rewrite 1 over negative cosine, that is equal to negative secant x. So we have verified the identity. So of course, you could also do some good verifying of identities using this identity. And okay, so that brings us to the end of this video. So hopefully that was helpful. Consider leaving a like or a comment or sharing with a friend. And otherwise, guys, I'll see you in the next video.